All right, today we're going to be talking about the other type of way to go ahead and solve quadratics, and this is the quadratic formula. Now, it is a formula, it is kind of big and scary, but I'm going to kind of break it down for you a little bit as we go through this. All right, so how do we go ahead and do this? The other thing we need to, before I get into how to do it, the other thing that you need to understand is what's called a discriminant. We're going to spend some time with that in the second part of the notes. But it's a special thing in the quadratic formula that we're going to go ahead and use to just go ahead and tell us some information. Uh, it's part of the way to go ahead and solve. It's just part of the first couple steps, but I'll talk about that when we get there. All right. So let's deal with the quadratic formula. All right. So the quadratic formula. Remember, everything's in the form ax squared plus bx plus c equals 0. So this big giant formula here is just, we're going to just plug the values in. So if I have 1, 5, and 6 here, I'm just going to plug them into the appropriate spots. Now this is negative b, or opposite of b. There's that plus or minus that we kept getting with completing the square. There's a square root part, b squared minus 4ac. And that b squared minus 4ac, that part underneath, that's what I was talking about with the discriminant. We'll talk some more about it in a little bit. And then divided by 2a. This looks like a big giant formula. And yes, we're going to have to memorize it, but it's really not that bad. What we're going to do first is we're going to do whatever is inside the square root part here. We're going to do that part first, and then it becomes actually pretty easy. So let's remember this b squared minus 4ac. That's the focus part first. All right, so let's do that. So here we have our quadratic formula. We're going to use it. Now the quadratic formula, if you notice at the beginning, it does equal 0. So I have to do that. This one equals 33. I can't have that. So I need to go ahead and write it into 0 form. So when I do that, I have 1, negative 8, and negative 33. Okay, so that's the first step. So now once we know those, we're going to substitute it in. Now we're going to go ahead and put it all together. But let's focus in on just this part here. B squared minus 4 times A times C. That 4 is always going to be there. It's always going to be minus 4. And then A is 1, B is negative 33. So let's simplify this in here. Ignore these other parts for right now. We'll get back to them. All right. 8 squared is 64, and 4 times 1 times 33 is 132. The double negative makes it a positive. Simplify this square root some more. 196. Now you do have to simplify square roots in this one. You're going to have much bigger numbers than we did with the completing the square. But the nice thing is we're not going to deal with any fractions. Square root of 196 is a perfect square. It is 14. And now we start worrying about this other part. So let's take a look at what happened there. In the quadratic formula, let me go back. It's opposite of b. It's negative b. There's a negative in front of that. So when I have a negative 8, it's going to be a negative 8. So there's going to be that double negative. So that's going to be positive 8. And the denominator is 2 times a, or just 2 times 1, or 2. All right. So now I have 8 plus 14 and 8 minus 14 divided by 2. So just kind of separating that. 8 plus 14 divided by 2 and 8 minus 14 divided by 2. 8 plus is 11 is 22 divided by 2 is 11. 8 minus 14 is negative 6 divided by 2, or negative 3. And that's how we do these. Now, the nice thing, again, is the fractions tend to not be there that we had in the completing the square, but we do have to simplify this square root a little bit more. A lot more going on within the square root. This one was a perfect square. It was 16. That was great, but not all of them will be. All right, so let's try another one. All right, so this is already in A, B, and C form. So again, I'm going to plug it all in. I'm going to ignore these two parts right now. I'm just going to focus here. So 34 squared and 4 times 1 times 289. When I do that, they actually end up canceling each other out, giving me 0. Well, that's great. Square root of 0 is just 0. So let's look at that other part, 2 times a. A here is 1, so that's 2. And over here is the opposite of b, so it's negative 34, so it's going to be positive 34. So positive 34 plus 0 divided by 2 is 17, and positive 34 minus 0 divided by 2 is also 17. There's only one solution here because this value gave us 0. That is a possibility with the quadratic formula and completing the square. We can get a 0 over here. And if we get a 0, we're only going to have one answer. Because if I add 0 or subtract 0, it's still going to be the same. If I was looking at the graph, remember our graphs, this is the one that just touches once. And that's how we get the one answer. The one we just got done doing would have crossed twice at those different numbers. This one only crosses once, or the vertex is sitting on the x-axis. All right, trying another one. 1, -6, and 2. A little bit easier numbers than the last couple. So again, plugging in, we're going to start with this. Let's start with this part here. Focus in on this first. So b squared, -6 squared is going to be 36. -4 times a times c, -4 times 1 times 2, so that's 8. So we're going to have 36 minus 8. 36 minus 8 is 28. Now let's put in the other parts. Opposite of b is 6, and 2a is just 2, or 2 times 1, right? Now 28 cannot be, is not a perfect square. So we have to simplify it. We have to do our birthday cake. And when we do that, it's 2 root 7. There's 2 2's that come out, and so it's 2 root 7. So we have 6 plus 2 root 7 over 2, and 6 minus 2 root 7 over 2. So here's our birthday cake they kind of did. Now notice with this, please, notice that these numbers here, these numbers on the outside, if all three of them can be divided by something, we have to do that. Same kind of thing here, we have to divide them. So 2 goes into all of them, so we're going to divide them. Notice I did not care about this square root of 7. That does not matter. It's just these numbers on the outside. If all three of them can be divided, we have to divide it. That's considered simplifying. So we have 3 plus square root of 7 and 3 minus the square root of 7. Now you can write it together. You could write it as 3 plus or minus the square root of 7. That would be fine if you want to separate it like they did. And then we can do an approximate solution. This approximate solution would have been what we would have gotten on our calculator, but it's not exact. These are the exact numbers, and we need those, or need to be able to find those. So it does cross twice, but at some decimals as opposed to integers. All right, keep trying these, work through a couple more. All right, this -6 over here we can't have, so we got to move it over. So when we go ahead, b is going to be a -6x. So that's why the -6 is in there. So we have -6 squared, which is 36. And then we have 4 times 1 times 13. 4 times 1 times 13 is 52. So 36 minus 52. That's going to give me -16. And anytime we have a negative number, we have to use our i's. So it's square root of 16 is just 4, and so it's 4i. So we have 6 plus or minus 4i over 2. And again, looking at these three numbers, 2 divides it, so we have to go ahead and do that. So this will be a 3, this will be a 2, and this is just a 1, so we won't even have to have a denominator. So it's 3 plus or minus 2i. And you can leave it like that because that is 2 different answers. If you want to separate it like 3 plus 2i and 3 minus 2i, that's fine. What does this look like in the graph? It looks like this. And notice that never crosses. And we told you before that that has no real zeros. Well, it doesn't. It has imaginary zeros. So the two imaginary numbers are here because they have the i's. That's what the whole imaginary part is. And that's why we know it doesn't cross, because the answers are imaginary. All right, so remember that discriminant part? We're just talking about the square root. It's that b squared minus 4ac. And that discriminant part, if it's greater than 0, we're going to have 2 answers because it's going to cross twice. Now, sometimes they can be integers, just like 4 or 5. They could also be like 1/2 or something like that, some exact value. But some of the times it's also going to be a square root answer. So either of those are possible. If it's a perfect square, then they're going to be a rational root like a 1/2 or a 4 or a 7. If it's not, then it's irrational and we'll have a square root like the one that we had was, square root of 13 or square root of 17, whatever it is. If it equals 0, that's the one that it just touches. That's the 0. That's the real root. And then if it's less than 0, and we get a negative in there, that's where we're going to get the two imaginary numbers, the complex roots. And it's going to look, the graph is going to look like this. So if I can get two real answers, I can get one real answer, or I can get two imaginary answers. Those are the only possibilities that I can go ahead and get. All right, so let's just talk about the discriminant as we're going to go ahead and do this. So remember, the discriminant is that b squared minus 4ac. That part inside the square root, the part that we do first. So 3 squared minus 4 times 1 times 5. 4 times 1 times 5 is 20. So it's 9 minus 20, or square root of negative 11. So this one here should not cross the x-axis at all because it's a negative number. It's going to be an imaginary. All right. They don't ask you to actually find the answer, but if we already know just by doing the discriminant part that it's going to be an imaginary number. So how about this one? B squared is 121. 4 times a times c, 4 times 1 times 10 is 40. So negative 121 minus 40, that gives me 81. That's a perfect square. That works out real well. And so we're going to have two rational roots. And that's what I have for you today.